Okay, welcome to chemistry classes. In this video, we have to discuss here nucleophilic substitution reaction part 2. Already we discussed SN1 and the SN2 reaction and their mechanism. Here in this video, we have to discuss here stereochemical aspects of nucleophilic substitution reaction. Nucleophilic substitution reaction and stereochemistry. Okay, relation between nucleophilic substitution reaction and stereochemistry. These are the things we have to discuss in this video. Clear? So here first we have to understand here some basic information about SN2 reaction. We know SN2 reaction. This is one example for SN2 reaction. SN2 reaction means primary alkyl halide reacted with the nucleophile such as OH minus produce primary alcohol. This is nucleophilic substitution reaction. This is SN2 reaction. SN2 reaction happening primary alkyl halide. Okay, so look here, this is primary alkyl halide, this is nucleophile. Okay, so during this chemical reaction, nucleophile attack this alkyl halide from backside. Okay, this is alkyl halide, this is halogen. Halogen, we know in this compound halogen, it is partially negative charge. Also nucleophile, they have negative charge. So it cannot attack from this direction because both are negative side, there will be a repulsion. So here nucleophile attack positively charged carbon from backside and form a primary alcohol with different configuration. Okay, so here the structure is inverted. Look here halogen is right hand side, but here alcohol is left hand side. So product formed with different configuration. Okay, so there is a inversion is happened in their configuration, in their structure. Okay, so we can say here during SN2 reaction proceed a product with stereochemical inversion. Stereochemical inversion happening in SN2 reaction. Okay, here another thing we have to understand here, SN1 reaction proceed a product with rasamization. Rasamization means SN1 reaction produce a racemic mixture. We will discuss more details about racemic mixture. Now you understand SN1 reaction proceed a racemic mixture. Clear? So here SN2 reaction stereochemical inversion, SN1 reaction rasamization. Understand this to remember this 2 points. Okay, next one we have to understand here plane polarized light and optical activity. Optical isomerism we already discussed in coordination compound. Optical isomerism means compound it rotate plane polarized light through clockwise direction or anti-clockwise direction. Such type of compounds are called optical isomer. Okay, so compound it rotate plane polarized light. There is two possibility for rotation after passing plane polarized light through a particular compound. This plane polarized light rotate clockwise direction or anti-clockwise direction. If the substance rotating plane polarized light clockwise direction, such type of compounds are called dextro-rotatory compound. Dextro-rotatory compound, or we can say D isomer, or we will represent positive isomer. Okay, plus isomer. Dextro-rotatory isomer. If the compound rotate plane polarized light anti-clockwise direction, substance rotate plane polarized light anti-clockwise direction, such type of compounds are called levorotatory isomer. Levorotatory isomer, or we can say L isomer, or we can say negative isomer, minus isomer. Okay, so this is optical activity and and plane polarized light and optical activity. Also remember here, racemic mixture means a mixture which contains equal amount of D and L isomer. Such type of mixtures are called racemic mixture. Racemic mixture. We discuss here Rasamization. Rasamization means a chemical reaction, it produces racemic mixture. So you imagine you have racemic mixture of glucose. So racemic mixture of glucose mean a mixture of glucose, it contains equal amount of D glucose and L glucose. A mixture, it contains equal amount of D glucose and L glucose. Such type of mixture called racemic mixture. Okay. Also you understand here dextrorotatory isomer and levorotatory isomer. Dextrorotatory isomer rotate plane polarized light clockwise direction. Levorotatory isomer rotate plane polarized light anti-clockwise direction. But racemic mixture means it contains equal amount of D and L isomer. It do not rotate plane polarized light. Because there is D isomer and L isomer, it will rotate clockwise direction. It will rotate plane polarized light clockwise direction and anti-clockwise direction in equal extent. That's why net rotation. That's why net rotation will be cancel each other. You understand? So these are the things you have to understand about plane polarized light and optical activity. Clear? Next one, we have to understand here molecular asymmetry, chirality and enantiomer. Next point we have to discuss here molecular asymmetry, chirality and enantiomer. Here first point we have to understand here asymmetric carbon. Asymmetric carbon, okay. Asymmetric carbon means a compound which contains stereo center. Stereo center. Asymmetric carbon mean you can understand like this. This is one example for compound which contain asymmetric carbon, a compound which contain carbon atom with 4 different groups. Such type of carbon called asymmetric carbon. Such type of center called stereo center. Look here, this is carbon, here CH3, here C2H5, OH and hydrogen. 4 different groups, carbon with 4 different groups. This is asymmetric carbon, this is stereo center. Stereo center. Okay, and see here one example, carbon, here 3 hydrogen and chlorine. So here 3 hydrogen, same atom. So it is not stereo center, it is not asymmetric carbon. Okay, even there is 2 hydrogen. Here imagine CH3 hydrogen, 2 hydrogen. Even it is not stereo center because 2 same atom. Okay, so this is the difference between asymmetric carbon and the compound which does not contain asymmetric carbon. Clear? Okay, after that we have to understand here optically active, optical active. Okay, so here the compound which contains stereo center or asymmetric carbon, they showing optical activity. We discuss optical activity here, plane polarized light. Okay, optical activity we can discuss different way. Another way, the compound which contain asymmetric carbon, they showing optical isomerism. Okay, so here optically active compound. Optically active compound mean compound which contain asymmetric carbon. Okay, and this type of compound they produce non-superimposable mirror image. This type of compounds produce non-superimposable mirror image. Non-superimposable mirror image means same this compound I did here. Okay, carbon with 4 different group. Okay, when you show this compound in a mirror, it produce its image like this. So here right hand side here, when you take this compound right hand side C2H5, here hydrogen. In this structure here OH, right hand side it is OH. So you cannot place this compound exactly over here. It's not matching because here right hand side C2H5 and hydrogen, here right hand side it is OH. So exactly you cannot keep this over here, you cannot place there. Okay, they are not superimposable. Okay, if you can keep same molecule over here, for example carbon, imagine here hydrogen, or here CH3, here hydrogen and here chlorine. Okay, its mirror image, it will be same like this. You can keep this molecule and its mirror image same way. They are superimposable. Okay, but in this structure this and this are non-superimposable. So compound which produce non-superimposable mirror image, they produce optical activity, they produce optical isomer. So here optical isomers of this compound are this. Okay, these are two optical isomers of this compound. So here one question, draw optical isomers of this compound. So you can do like this. These are the two optical isomers of this structure. Clear? So condition for optical isomerism, the compound it contains chiral carbon. What do you mean by chiral carbon? Chiral carbon means carbon with four different different atom or different molecule. Okay, this type of carbon called chiral carbon, or we can say asymmetric carbon or stereo center. These are the different name. Clear? So here these are the things we have to remember here. Okay, here this is chiral carbon and here this is achiral carbon. Achiral carbon means carbon with the same group, same atom or same molecule. Okay, this is achiral carbon, this is chiral carbon. Achiral carbon, they produce superimposable mirror image. Okay, they are not optical isomer. Okay, so condition for optical isomerism, the carbon must contain four different atom or different molecules. Clear? Okay, so here we discussed here symmetric carbon and asymmetric carbon. Okay, so we can take some organic compound and we can explain this asymmetric and symmetric carbon. See here, here propan-2-ol and butan-2-ol. Okay, we know propan-2-ol means 3 carbon atom and OH. Okay, 3 carbon atom and OH. Okay, 1, 2, 3. In second carbon there is OH. That's why we can say this is propan-2-ol. This is butan-2-ol. Here 1, 2, 3, 4. Here second carbon there is 2 OH and there are total 4 carbon. So butan-2-ol. Okay, butan-2-ol and propan-2-ol, these are the example. Okay, so see here propan-2-ol. Here this is the middle carbon. Here CH3, here CH3, here OH and hydrogen. So 2 CH3. So this is not asymmetric carbon, this is symmetric carbon. Okay, so we can draw this compound like this. Look here, carbon, middle carbon, CH3, hydrogen and OH. So there is 2 CH3. So its mirror image coming like this. Clear? And here this is symmetric carbon and these are not optically active. Condition for optical isomerism, there must be a stereo center, there must be a chiral carbon with 4 different group. But when you take butan-2-ol, this is structure of butan-2-ol. Okay, here this is middle carbon, here it is CH3, here CH3, CH2, CH3. So 2 carbon and 5 hydrogen, C2H5 and hydrogen and OH. So this is the carbon, one side CH3, another side C2H5, then OH and hydrogen. So carbon with 4 different groups. So this type of compounds are chiral carbon and this is the compound with the stereo center. They're showing optical isomerism. Clear? So this is the structure. Look here, this is middle carbon, here CH3, C2H5, hydrogen and OH. Okay, it's a mirror image coming like this. Okay, there is stereo center. This is optically active. Okay, here we have to understand one more point. enantiomer means same like a racemic mixture. We already discussed Rasamic mixture. Rasamic mixture means a mixture which contains equal amount of D and L isomer. This is racemic mixture. Same definition for enantiomer. Enantiomer means compound, a mixture which contains equal amount of D and L isomer. Okay, that is enantiomer. Enantiomer usually we will represent like this. DL glucose mean it is a racemic mixture. It contains equal amount of D and L glucose, that is DL glucose, or we can represent like this, plus minus, plus also minus. Okay, same like that, DL glucose plus minus glucose mean it is racemic mixture, or you can say it is enantiomer. Clear? Okay, next one here we have to understand here retention. Retention means the spatial arrangement of different bonds. Okay, spatial arrangement of different type of chemical bond around asymmetric carbon atom in a chemical reaction. This is called retention. Okay, retention means spatial arrangement of bonds, spatial arrangement of chemical bond around asymmetric carbon atom during a chemical reaction. This is retention. Okay, we have to understand more details about retention and some example we will discuss now. Okay, so here we discuss retention. Okay, so here one example for retention here. Look here three different, this is showing three different chemical reaction. This is one chemical reaction, this is second chemical reaction, and this is third chemical reaction. And imagine this is one compound. Here this is chiral carbon. Okay, this is middle, this is chiral carbon with a different group. Here hydrogen, CH3, C2H5, and here X mean one of the group. Okay, maybe nucleophile or halogen or anything. Okay, so here X. Okay, and here this is substitution reaction. X substitute with Y. During this chemical reaction, X substituted by Y. Okay, so you check these two structure. Here X replaced by Y, but there is no any configuration change. Okay, you can check here same bonds over here. Okay, so this type of product, you can say here product formed by retention configuration. Okay, retention configuration mean only substitution happened. Okay, after chemical reaction, the direction of bonds, there is no any change in the direction of bond. This is the retention, product formed by retention. Okay, also you check this chemical reaction here. You can see here same compound, substitution reaction with Y. Okay, this is the product formed. You can see here the configuration changed. Okay, configuration changed here. Here CH3, this bond in right hand side. Here in product, this CH3 with this bond left hand side. Okay, and X substituted by Y. Here X was in left hand side. Here it is right hand side. So the configuration totally changed. Okay, and this is the product formed by inversion. Okay, inversion. We discuss SN2 reaction happen this type of inversion. Okay, SN2 primary alkyl halide with nucleophile inversion happened. Inversion. So this is inversion and this is retention. Retention, there is no change in direction. Okay, third possibility here, this chemical reaction here Y reactor, and here 50-50% formed. 50% of the compound, 50% of the product formed by retention, 50% of the compound formed by inversion. So this is a mixture. This mixture contains two different type of product formed by inversion, also product formed by retention. This type of mixture called Rasamic mixture. Rasamic mixture, or you can say enantiomer. Okay, and these are optically inactive. Okay, there are D and L isomer. Okay, so rotation to clockwise and anti-clockwise direction equal extent. So net rotation will be cancel each other, and this type of compound will be optically inactive. Clear? So here remember, this is retention, inversion, and this process is called Rasamization. Process by which Rasamic mixture formed. This is Rasamization. So already we discussed SN1 reaction is Rasamization, SN2 reaction is inversion. Okay, so in SN1 reaction coming in this category, Rasamization. In the beginning we discussed SN1 reaction is Rasamization, SN2 reaction is stereochemically inversion. Okay, so this type of product formed in SN2 reaction, this type of product formed in SN1 reaction. Okay, so product formed by retention, this is optically active. Okay, product formed by inversion, also it is optically active, but Rasamization, it is optically inactive. Clear? Okay, next one we have to summarize here. Optical activity and SN1, SN2 reaction. First we have to discuss here SN2 reaction. We know SN2 reaction takes place in primary alkyl halide. Okay, it is bimolecular reaction. In SN2 reaction, primary alkyl halide takes place. Primary alkyl halide involved SN2 reaction. This is one example for primary alkyl halide. Okay, and here this is carbon and halogen, CX bond, or here CX bond means carbon halogen bond. Here carbon, it is electropositive and halogens are electronegative element. Okay, so here halogen, it is electronegative element. Okay, so nucleophile cannot attack this direction, already we discussed. Here nucleophile cannot attack this direction because nucleophile, it is negative charge. Here already negatively charged halogen, so there will be a repulsion. So nucleophile will attack electropositive carbon this direction. After that a product formed, a primary alcohol formed. Here OH will be this direction. Okay, so there will be an inversion. Okay, there will be an inversion in the configuration. Okay, and here we discussed here during SN2 reaction, product formed with inverse configuration in SN2 reaction. Okay, so here product formed, it is optically active compound, it is optically active product. Okay, so these are the things we have to discuss, we have to understand in SN2 reaction. Okay, so let us discuss now SN1 reaction. We know SN1 reaction takes place tertiary alkyl halide. Okay, in tertiary alkyl halide involved SN1 reaction, during this chemical reaction carbocations are formed. During SN1 reaction carbocations are formed. Okay, tertiary carbocation is more stable. Than primary carbocation and secondary carbocation. That's why tertiary carbocation involve this type of chemical reaction. Okay, so here in tertiary alkyl halide, tertiary carbocation formed. This tertiary carbocation is more stable than primary and secondary carbocation. That's why in SN1 reaction, tertiary alkyl halide involved in SN1 reaction. Okay, so here a tertiary carbocation formed. This tertiary carbocation, it is polar and it is sp2 hybridized. Okay, here carbocation formed, it is polar, also it is sp2 hybridized. So here in SN1 reaction, a carbocation formed. Okay, so in this carbocation, nucleophile can attack either side. Okay, here nucleophile can attack this side or this side, right side or left side. Nucleophile can attack carbocation. In previous case, SN2 reaction, here only one direction, attack of nucleophile possible, only one direction. Okay, this right hand side not possible. Okay, because there is already negatively charged negatively charged halogen, it will repel with negatively charged nucleophile. But in this case, there is no this type of repulsion. So here attack of nucleophile possible in two direction. Okay, so there will be a mixture of product formed, a 50-50 percentage mixture of product formed. Okay, so here imagine nucleophile attacking this direction. So product formed here, alcohol, tertiary alcohol, here OH is in left hand side. Okay, or imagine OH attacked in right hand side. So tertiary alcohol formed, here OH is in right hand side. So actual reaction, a mixture of product formed. Okay, a mixture of product. So in SN1, a mixture of product formed. This is the reason a carbocation formed. Nucleophile can attack either side, left or right hand side. So a mixture of product formed. Okay, so here it is dextro-rotatory butane 2-ol. Okay, and here this is levo-rotatory butane 2-ol. So here it's mean here a dextro-rotatory product and levo-rotatory product formed in same reaction. So this is a 50-50 percentage product, 50% dextro-rotatory product and 50% levo-rotatory product. That's why we will say this is racemic mixture. In SN1 reaction, a racemic mixture formed, or we can say enantiomers. These two products are enantiomers and they are optically inactive. Why they are optically inactive? Because they contain 50-50 percentage dextro and levo-rotatory. One of the compound rotate plane polarized light clockwise direction and another one anti-clockwise direction. So net rotation will be cancel each other. So here net rotation will be cancel each other, so the product will be optically inactive. So here you have to understand SN2 product, it is optically active. Okay, and here inversion product formed with the inverse configuration. Okay, in SN1 rasamization happened, okay, and here the products are optically inactive. Okay, so these are the things you have to understand here. Clear? Okay, next one we have to discuss here elimination reaction. Next point we have to discuss here elimination reaction. Elimination reaction means alkyl halide which contain beta hydrogen. Alkyl halide which contain beta hydrogen. It react with alcoholic KOH. Okay, KOH which dissolved in alcoholic medium, ethanol medium. Alcoholic KOH reacted with alkyl halide, it formed alkene. This type of chemical reactions are called elimination reaction. So elimination reaction means alkyl halide which contain beta hydrogen. What do you mean by beta hydrogen? See here CH3 CH2X. So this is one alkyl halide. Okay, here CH3 CH2X. Here halogen attached to this carbon. So this is alpha carbon. Alpha carbon means carbon in which halogen is attached. This is first carbon, that is alpha carbon. And this is next carbon, this is beta carbon. So this beta carbon, this contains hydrogen, CH3. There are 3 hydrogen. Okay. So here there are 3 hydrogen. One of this hydrogen and this halogen will be removed. Hydrogen halide, HX, in presence of alcoholic KOH. Okay, and between these 2 carbon there will be a double bond. So after elimination reaction, the product is alkene. This reaction takes place in presence of alcoholic KOH. Also alkyl halide which contain beta hydrogen. Beta hydrogen mean this is first carbon, this is second carbon, this is beta carbon. Beta carbon, it contains hydrogen. One of this hydrogen combined with the halogen, removed hydrogen halide, hydrogen chloride, hydrogen bromide, etc. Okay, and alkene will be the major product. Okay, alkene is the product. This type of chemical reactions are called elimination reaction. Elimination reaction. Okay, and here you have to understand sometime alkyl halide which contain more than 1 beta carbon. More than 1 beta carbon. Okay, so look here, example here, this is one example here. Here this is 2 bromobutane. Okay, first carbon 1 2 3 4, here 4 carbon, and here halogen is attached over here. I told you before, halogen attached carbon, that is alpha carbon. So here halogen attached over here, so this is alpha carbon. Okay, so this is adjacent carbon, here it is beta carbon. This is beta carbon. So in this case there are 2 beta carbon. This is alpha carbon, so this is beta carbon. Also this is beta carbon. So here this is alpha carbon and here 2 beta carbon. But here in this case only one beta carbon, so only one possible product. But this case there are 2 possible products. One product here halogen, one of this hydrogen and halogen will be removed. So the product will be CH2. Here hydrogen and halogen replaced. So double bond will be here. CH2 double bond, CH single bond, CH2 CH3. This is one product. Another possibility, so this is one possibility. Another possibility, beta hydrogen from here, this hydrogen or this hydrogen, one of this hydrogen and bromine will be removed. Okay, so here CH3, CH double bond, CH, CH3. So these are the 2 possible products. So the compound which contain more than 1 beta carbon, so there are a mixture, there are 2 possibilities, there will be a mixture of product. Okay, we discussed in SN1 reaction there will be a mixture of product D and L isomer. Similarly here in elimination reaction there will be a mixture of product. Okay, elimination reaction, here compound which contain more than 1 beta carbon, so there will be a mixture of product. So here we have to understand according to Saitsoff rule. According to Saitsoff rule, according to this rule, okay, here alkene, the major product will be, here 2 possible product, the major product will be alkene in which carbon-carbon double bond, the compound which contain more alkyl substituted alkene. The major product will be more alkyl group substituted alkene. Look here, this is carbon-carbon double bond. Here this is one alkyl group, here also another alkyl group. Here 2 alkyl group is substituted. 2 alkyl group substituted. But here it is 2 hydrogen, but here it is C2H5. Here one alkyl group substituted. So this is the product in which More alkyl groups substituted to alkene. Both side alkyl groups substituted. So here this is major product. This will be major product. Okay, and this will be minor product according to Saitsoff rule. Okay, so here Saitsoff rule saying during dehydrohalogenation. Elimination mean here hydrogen and halogen is removing. Hydrogen and halogen is removing. So we can say dehydrohalogenation. Dehydrohalogenation, this DE, it represents elimination, removal. Okay, so dehydrohalogenation, during dehydrohalogenation, here preferred product is greater number of alkyl substituted carbon-carbon double bond. Greater number of alkyl groups substituted to carbon-carbon double bond. Such type of alkene will be major product. That is Saitsoff rule. According to Saitsoff rule, during dehydrohalogenation, a product formed, more number of alkyl groups substituted alkene. This will be major product and another will be minor product. So here we discussed about elimination reaction. Elimination reaction means halogen and one of beta hydrogen will be removed in presence of alcoholic KOH. Okay. And if there is 2 beta carbon, there is a mixture of product. The major product will be more alkyl groups substituted alkene. Okay, so this is the things you have to understand about elimination reaction. Okay, here last part of this video we have to discuss here reaction with metals. Alkyl halide reacted with metals form a special type of compound. Alkyl halide reacted with metals form organometallic compound. Okay, so here you have to understand alkyl halide reacted with metals form organometallic compound. Organometallic compound, this compound contain carbon metal bond. Organometallic compound, it contain carbon metal bond. Okay, important example for organometallic compound, Grignard reagent. Important example for organometallic compound, it is Grignard reagent. Grignard reagent mean RMGX. RMGX, this is Grignard reagent. RMGX mean, example for RMGX, CH3MgCl. This is one example for Grignard reagent, CH3MgCl, or you can say C2H5MgBr. This type of compounds are Grignard reagent. Here CH3, C2H5, this represent alkyl group R, and here magnesium, then there will be halogen. So generally we can say Grignard reagent mean it is RMGX. Clear? So in RMGX here you have to understand in alkyl in Grignard reagent, here look here RMGX. So here carbon and magnesium, there is a direct bond between carbon and magnesium. That's we said here carbon metal bond. It contains carbon metal bond. So in RMGX, carbon magnesium bond, it is covalent in nature. Okay, carbon magnesium bond, it is covalent nature. Magnesium halogen bond, this is ionic in nature. So in RMGX, carbon magnesium bond covalent, magnesium halogen bond, it is ionic. Okay, RMGX, Grignard reagent, it is highly reactive. Grignard reagents are highly reactive. It reacts with a source of hydrogen. Okay, a compound, it provides hydrogen. Such type of compound, we can say a compound which provide hydrogen. Such type of compound reacted with the Grignard reagent, it will change to alkane. So Grignard reagent, it is highly reactive. It will react with a source of hydrogen and form alkane, or you can say hydrocarbon. Clear. So here we discuss alkyl halide reacted with metal, it form organometallic compound. Okay, organometallic compound, it contain carbon metal bond. Important example for organometallic compound, it is Grignard reagent. Grignard reagent is one example. Example for Grignard reagent is general formula RMgX. Okay, here carbon magnesium bond covalent, magnesium halogen bond, it is ionic. It is highly reactive. It will react with a source of hydrogen. It produce hydrocarbon. Clear. So look here, this is a compound, it provides hydrogen. So here alkyl halide Grignard reagent reacted with water, it form alkane. Okay, alkane, or you can say hydrocarbon. So this is the major product. Okay, so here we have to understand a named reaction, Woods reaction. Woods reaction also reacted, it is related with RMgX, Woods reaction. Woods reaction. Here alkyl halide will be alkyl halide reacted with sodium. Look here, this is alkyl halide. Alkyl halide reacted with sodium in presence of dry ether, a hydrocarbon will be formed. Okay, so here this Woods reaction is related to alkyl halide, not RMgX. Okay, so here Woods reaction, this is named reaction, it is related to alkyl halide. Alkyl halide reacted with sodium in presence of dry ether, it produce hydrocarbon. Okay, so this reaction is called Woods reaction. So here these are the different chemical reactions we have to understand. We have to understand reactions, chemical reactions of alkyl halide. So chemical reactions of alkyl halide, we discuss nucleophilic substitution reaction, SN1 SN2 reaction. Then we discussed elimination reaction. Then we discuss reaction with the metal. Okay, so nucleophilic substitution reaction, we have to study many things. Okay, stereochemistry of nucleophilic substitution reaction, but here elimination and reaction with metals we finished now. Okay, so here this is reaction with metal. Okay, and Woods reaction, you remember alkyl halide reacted with the sodium. This is also reaction with the metal, reaction with the sodium in presence of dry ether, it produce hydrocarbon. Clear. So these are the different things we have to discuss in this video. Rest of the things we will discuss next video. So thank you for watching.